I got a couple of battery powered fans here. This one is a GeekAire and it's rechargeable. You can run this thing with it plugged in or run it off the rechargeable battery. It is variable speed and it's got battery charge indicator lights. Here's the power supply for the fan. Output is 12 volts at 1.5 amps, as DC obviously. And here's the end that connects to the fan, right there. Here's the information sticker. Model CF3. This fan is very sturdy, and it's got a really sturdy handle. And the grills are pretty sturdy. So it's a good fan, and it's really nice to have these for when the power goes out. Because if it's summertime and you get storms or something and the power goes out, you're going to be really hot if you don't have something like this. And of course, like I said before, it can run just off the power adapter as well. You don't have to run it off the battery. I don't have the fan plugged in yet, I'm just going to run it off the battery. I got the power adapter plugged in, but it's not connected to the fan, so let's just go straight up to high speed. And we are fully charged according to the indicators. This fan can get very quiet and very slow. It's obviously not moving much air at this speed, but yeah, it's definitely a variable speed. I'm not sure if this is a brushless or brushed DC motor. That one I'm pretty sure is brushed. But, well, let's plug it in. And that's what the charging current is. The fan's not running right now, obviously. Alright, let's go all the way up to high. Current did not increase at all with the fan running. So unplug that and see if we get a change in speed. It actually runs faster on the battery than it does with the adapter plugged in. It's interesting. Yeah, there's no difference in amp draw whether or not the fan is running. It's possible that, when the battery is fully charged, it won't have any amp draw, and then when you turn it on, you'll get some, but as it is right now, with the battery charging, it doesn't change whether the fan is on or off. Went up a little bit when I turned it on to high speed, but barely noticeable. And here is the Holmes fan. This one is also variable speed. Here's the model information. Now this one is not rechargeable. It can run on either the power adapter or it can run on batteries. I'll try and take the cover off. Got the bottom battery cover off, and this thing runs on 6 D-size batteries. I got the power adapter disconnected, so I'll just run it on batteries real quick. These batteries are low, so it's not going to run very fast, but I'll just go all the way up to high. Yeah, it's running pretty slow right now. And this does tilt. Alright, I'm going to plug it in now. I still got it running on battery because I want to show you what it does as soon as you plug this in. And no, it's not plugged into the outlet yet. Connect this, and that takes the batteries out of the circuit. It just shut off. And now I'll plug it in and the fan will start. So there you go, it's running a lot faster now. And we are pulling 0.12 amps and 10 watts. So our power factor is pretty low, which I guess is normal for switching power supplies. This thing is pretty powerful. Let's do the variable speed. That's the lowest speed. And off. Go back to low. And the current draw changes as you adjust the variable speed control. Not very much, but it does change. This fan was purchased a few years ago on a day that we were expecting some pretty severe thunderstorms. We got it in case the power went out and we'd still have a fan. And sure enough, the power did go out, and I ended up using this at night because it was hot. Now, there are versions of this that are rechargeable, but this one, it's either D batteries or have it plugged in to the power adapter. Oh yeah, this thing is capable of tilting. I would definitely recommend having fans like these around for power outages. I'm probably going to get some more eventually because when the power goes out in the summertime and it's hot, it can get pretty miserable if you don't have a fan.